Welcome back. This is chapter 13, Quasi-Experiments and Small-N Designs. Our discussion of this chapter is going to be fairly quick on the small-N designs. Even though they are very important, we're just going to give an intro to those. Quasi-experiments are pretty common, and so we're going to kind of show how those are similar to correlational studies. So when it comes to a quasi-experiment, we're going to talk about how it differs from a regular experiment, what makes them different, what makes them useful. And then small-N designs, the name tells you a lot. It's usually only using a few individuals, usually a lot of repeated measures with those. So when it comes to quasi-experiments, it's similar to regular experiments in that it has independent groups and repeated measures, two separate ways of looking at changes. We're going to talk about the internal validity of quasi-experiments and how to balance priorities there. And finally, how they're very, very similar to correlational studies. First, we're going to talk about a few examples of quasi-experiments. So this one is an independent groups quasi-experiment. It's the psychological effects of walking by a church. So this table gives you an idea of what they're looking at. So these are individuals that walk by a religious landmark, and these are people that don't walk by the religious landmark. They walk by just some non-religious building. And it looks at the percent that believe in God, their religiosity, etc. So this study, all they did was find people that walked past a religious building and interviewed them. And at another place, they found people that walked past a non-religious building and interviewed them. So in this study, there's an independent variable. It's a type of building, either religious or not, and several dependent variables. So you have belief in God, religiosity, political conservatism, etc. So it's quasi-experiment because we didn't randomly assign, or even assign at all, whether they were walking in front of a religious building or a non-religious building. So the people just chose it themselves. If they happened to live close by, that was probably their choice that they made. And so they walked past the building. So it's totally up to them. So in an experiment, we would assign them to one of those conditions. In a quasi-experiment, the individuals just choose. Another example of independent groups quasi-experiments is the psychological effects of cosmetic surgery. So what they did in this one is they found people that either got cosmetic surgery or didn't. Again, it was their choice. The researchers didn't assign it. And then they compared how they were at different time points to people that didn't get cosmetic surgery. So one of the things they compared was self-esteem of people who underwent cosmetic surgery and people who only considered it. And so here is the results. The book talks about all these. We'll just talk about this one here. So with self-esteem, you have the ones that got surgery. It looks like it goes up a little bit. Where the people that were considering it but decided not to, it went down. So some things to consider when it comes to quasi-experiments is, can we say that that was causal? That it was a cosmetic surgery that helped these people maintain their self-esteem and these people lost it because of that? Some to consider, some we'll talk about a little bit more. When it comes to repeated measures, quasi-experiments, this is one. Food breaks and parole decisions. This is where researchers assess the proportion of favorable parole decisions made by judges before and after breaks. So about 70% were favorable earlier, and it slowly goes down until the food break, and then it pops up after, and again, has the same pattern. So this paper, what they were saying is that the decisions that judges are making were heavily influenced by whether or not they were hungry. Now the question again is, can we say this is causal? Did the food cause the change in decisions here? Another example, repeat measures, is assessing the impact of a healthcare law. So this one, in 2010, the federal government enacted the Affordable Care Act, requiring all citizens to acquire health insurance or face fines. But just 4 years earlier, Massachusetts did something really similar. And so a team of public health researchers decided to evaluate whether that law in Massachusetts made any difference in people's access to health care. So this is the percentage unable to see the doctor, so higher is worse. And so they're looking at the pattern over time in states that are close to Massachusetts, so ones that are similar in Massachusetts itself. And so you actually see from the line that maybe it goes down a little bit, but it could have been going down anyway somewhat. So here, this is again a quasi-experiment because we didn't randomly assign which states got the law. Instead, it was just Massachusetts chose it, and the neighboring states didn't, and so we can compare those. So again, can we say anything about causality here? Something to keep in mind. So when it comes to internal validity and quasi-experiments, 4 things to keep in mind. Selection effects. So this is essentially any unaccounted for differences between the groups. So this is only relevant to the independent groups designs. But this is anything that is related to that individual selecting to be in one group or the other. So for the walking by a religious or non-religious landmark, those individuals at some point selected to live close or not too close to a religious landmark. So that could come into play here. The design confounds, so there can always be extraneous variables that may influence the results of our study. So it could be a variable that impacted them being more religious and living where they live. That has nothing to do with them walking past the church. So it could be that neighborhood was more religious, they heard that, and so they wanted to move there. But it had nothing to do with the fact that there was a religious landmark there. Another one is maturation. So in an experimental or quasi-experimental design with a pre-test and post-test, this is basically any observed change that could have emerged more or less spontaneously over time. So something that just happens. We talked about this in schools. Kids are just always learning, so if you just do a pre-test, post-test, then they may just learn because they're in school, not because your type of teaching is particularly good or not. Then the last one is history of threats. So when an external historical event happens for everyone in a study at the same time as a treatment, which makes it so you can't say whether or not your treatment had any effect there. So these last 2 are really relevant in pre-test, post-test, or repeated measures designs. These ones come into play more with independent groups, but this one can really pop up anywhere. Other things to consider that we talked about before is regression to the mean, attrition. So when you have over time, people just don't answer questions. So you might have everyone at baseline in 3 months, but maybe a few people don't respond here, and then at 1 year, people just stop responding. There's also testing and instrumentation threats, and observer bias always plays a role, placebo effects. So the same things that happen in experiments can also happen in quasi-experiments, but in quasi-experiments you have more because you didn't randomly assign people to groups. So when you're using quasi-experiments, it can be useful for a number of reasons. One is you can take advantage of real-world opportunities. For example, the Massachusetts law. So lawmakers decided to put that into effect. So as researchers, you could be like, oh, that's an opportunity to see if that law actually has any effect on the individuals in that state. The external validity, because quasi-experiments are very real world, they happen often without any intervention on the researchers, there's no lab, it actually can have really good external validity. Quasi-experiments can also help with ethics. So for example, if we're doing a study on smoking, it's not ethical to randomly assign people to smoke or not smoke. So what we can do is use a quasi-experiment where the individuals already chose whether or not they want to smoke or not. And then we can follow them and see what happens. And then when it comes to construct validity and statistical validity in quasi-experiments, usually quasi-experiments show excellent construct validity for the independent variable, mainly because you're not the one designing it. It's already chosen by the individuals. For example, in the religious landmark study, people really did or did not walk by a church. It's not too hard to measure that, so the construct's really good. In the judicial decision-making study, judges really did or did not get a food break. So that, again, is easy to measure. So to assess a quasi-experimental study statistical validity, you could ask how large the group differences were, so look at the effect size, and whether the results were statistically significant. But with those in mind, with statistical validity, it's important to consider the threats that we just talked about. Because maybe the significance and the effect size are not actually all that meaningful because we have design problems or we have selection effects. So if you're thinking, this seems a lot like a correlational study, the way that we've talked about it, you're right. They can look really similar to correlational studies. And they actually have a lot of things in common. So in general, both may use independent groups designs. Correlational studies not necessarily having to do that, but they both can. Neither of them use random assignment, and neither use manipulated variables. So neither of them you're actually actively manipulating a condition or giving an intervention. So in a lot of ways, these two are very similar. So in what ways are they actually different? So in correlational studies, researchers simply select some people and measure two variables and test the relationship between them. In quasi-experiments, however, the researchers might obtain groups by targeting key locations like the religious landmark study or seeking out comparison groups provided by nature or by public policy. So whereas correlational researchers primarily measure variables in a sample and analyze their relationships, quasi-experimental researchers more actively select groups for an independent variable. That is, in quasi-experimental groups, something's already happening, and we actively go find those people that are doing those things. So if it was with smoking, we would find people that don't smoke and people that do. Correlational studies would just get a sample and ask and measure questions and correlate them. When it comes to small n designs, we're just looking at a few individuals. So consider large n, the stuff that we've talked about before, where you get more of a sample of people. And participants are grouped. So in large n designs, the data from an individual participant are not of interest in and of themselves. It's usually the means of the groups. We're comparing the group averages. With small n designs, we're usually looking at each individual separately. We're not aggregating their data, and we're not getting the average of their data. So usually, each individual is presented in a small n design. So we're going to talk about a couple versions of this. So one is a case study. We're also going to talk about 3 small n designs that are used in the wild a lot. A few other examples quickly, and then we're going to evaluate the 4 validities and small n designs. And although we go through this fast, this is a really important and well-validated design if you want to use it. So a case study, research on human memory. So Henry, this guy pictured here, suffered from repeated debilitating epileptic seizures. It was enough that he really couldn't live his life at all. So a surgeon excised the front half of his hippocampus on both the right and left sides. So they removed part of his brain. After that, for 40 years, he was followed. Researchers extensively covered HM is what they referred to him as, to see what things he couldn't do as well now that some of his hippocampus was taken out. And so they developed a lot of tasks to have him actually try things out, and with his participation, which he continued to offer, which was awesome, it helped document the biological separation between declarative memory, or knowing that something happened, and non-declarative memory, knowing how to do something. So for an example, one group taught Henry to trace a star pattern with a pencil while seeing his hand only in a mirror, which is actually, if you've ever tried it, it's a very tough task. Over repeated trials, his mirror tracing skill improved just as quickly as that of someone with normal brain function. So this is what's called his non-declarative, like knowing how. His brain picked up on how to do it. But each day when he saw the task, he'd claim he had never seen it before. He could not remember it. And that's declarative. He didn't know that he had ever practiced it, which is really interesting. So this is an example of a case study. It's a single individual that they learned a lot from. But the issue is in case studies, there can be some problems. So for one, this individual also had other issues because of anti-seizure medication. So it's difficult to narrow down the specific region that's responsible for each behavioral deficit. So this can be an internal validity issue where we don't know what's causing the change. Why is he not very good at non-declarative or declarative memory and great at declarative or non-declarative? Another disadvantage involves external validity. Participants in small-N studies, especially case studies, may not represent the general population very well. So we can't be sure whether the results from Henry would generalize to other individuals in similar situations. So when it comes to small-N designs, first one we wanted to talk about was a stable baseline. So this is where we are measuring someone and we wait for their baseline to get really stable. So it's the exact same for 3 times. So whatever their behavior is not changing. So we know, well, it doesn't look like anything's changing in their life that's making this change. So that's our baseline. And then right when we see that it's not changing, we say, okay, now we can start this intervention. And so in this case, we can give an intervention and watch what happens after that. So in this case, without the intervention, it's pretty clear that nothing was changing down here. Once the intervention was given, it shot up almost to 100%. So even though this is just one individual, this would suggest this intervention may have a lot of merit, especially for this individual. Another way of doing this is what's called a multiple baseline design. And this is basically where you have, in this case, 3 individuals. So you have John, Sally, and Bob. And with John, you have a baseline measure. And then you just start the intervention, watch what happens. And another person, you let the baseline go longer, and then start the intervention. And then another person, you let go longer, and then start the intervention. And so what you're looking for is if the intervention seems to work right when it starts in each individual, that's telling you that it's probably not a history effect that's happening to all three people, because it would be weird if something happened right here for this person, right here for this person, and right here for this person. It's possible, but really unlikely. So by staggering when you give the intervention to each person, you're actually drawing out potential history effects that could just be happening in the wild, like an election year where there's a lot of talk about something that can be triggering for someone with PTSD. In that case, giving a staggered response would help you rule out anything else that's happening out there. Last one we're really going to give a good example of is reversal. This is where you have a baseline, you give the treatment, you then stop the treatment and give a baseline, and then give the treatment again, and maybe a baseline again, and then a treatment again, and maybe baseline. This one doesn't have to be so many times, but the more often you do it, the more it shows how consistent the effect is. So consider these three situations. So stable baseline, multiple baseline, and reversal. Of the three, are there situations where one is more useful than the other? And are there some situations where one might not work? So one place where this one's particularly useful is if you really don't have access to very many people. So multiple baseline is tough. So what you can wait for is just the baseline to get stable enough for you to say there was nothing happening, and then start the intervention then. This one's really good when you have something that might not go away. So maybe in this example right here, it's 3 different children with autism who feared dogs initially, but they were had this contact desensitization plus reinforcement, so they were given this treatment to help them not be scared of dogs. And so they were actually able to make the distance from the dog that they were able to stay at much smaller, basically 0, so they could be next to the dog. This situation is probably going to stay with them. They're probably not immediately just going to be like, oh, I'm scared of dogs again the second we stop the reinforcement. Because of that, a reversal wouldn't be good. So if it's something that's going to stick with them, so we have a baseline and then a treatment happens and then we do a baseline. If it's something that just sticks around, then it's not going to change here. It's just going to stay a straight line here. So multiple baseline would be a good choice there. Reversal is more something that the treatment only works when something is happening or something is present. So you can give it and then take it away. And then you can give it back and take it away and see what happens. So each of them, they help in different aspects, different situations. And they're all really important designs to help you understand what's happening with just a few individuals. So there's other examples of Small-N studies. Piaget in 1923 was a developmental psychologist interested in cognitive development in children. And he developed his theory in large part through careful observations of his own 3 children. So he watched his own children. And ideas like conservation of liquid, illustrated in the figure where this is the exact same amount of liquid, but this one's taller. So most kids will assume this is more liquid, even though they saw it, that it was equal here, and they saw it get poured in here. He was able to understand that that was a developmental milestone to be able to understand that the amount of liquid in this cup doesn't change in this one. So although the sample size of 3 is obviously a very small n, Piaget used very careful systematic observation well-defined constructs and extensive replication to support his conclusions. So even with a small sample size, if you plan things out well enough, you can still get really useful information. There's other examples that's talked about in the book of small-N studies. I'm not going to go into this one right now. We're going to instead go into the 4 validities in small-N designs. And this can be surprising. Even though the N is small, the internal validity can be very high if the study is carefully designed. The issue where small-N designs struggle the most is usually external validity. It can be problematic depending on the goals of the study. So if you want this to generalize to all individuals with autism or all children, small-N designs can sometimes struggle there because there can be very unique things about the individuals that you have in your small-N study. When it comes to construct validity, it also can be very high if definitions and observations are precise. So it's like other experimental techniques. If you define things well enough and you observe them well enough and measure them well enough, construct validity can be very high. In small-N studies, when it comes to statistical validity, it's not always relevant. Often what they will do is just report these kind of figures, show the data for each individual and how things changed, and often will not even report any statistical analyses. They won't report means, standard deviations, won't use ANOVAs or t-tests or anything like that. So that's it for this chapter. Hopefully this was helpful in painting some pictures of some alternative methods you can use. It's really late in the year, but if you find that one of these really fits for your study, let me know and I can help you make sure that this gets designed well so you can put it in your proposal. All right, thank you.